we want to use the shell method, sometimes referred to as the tubes method, to determine the volume of a solid formed by rotating the region bounded by y equals x squared, y equals 0, and x equals 2 in the first octant about x equals 4. Let's first graph the bounded region as well as the axis of rotation. So looking at our graph below, y equals x squared is this blue parabola, y equals 0 is the x-axis, and x equals 2 is this vertical line. So this yellow region is the bounded region, which will rotate about x equals 4, this red vertical line. So if we rotate this region about x equals 4, it would give us this solid here, and our goal is to find the volume of this solid. Whenever using the shell method or tubes method to determine a volume of revolution, it's always helpful to sketch a rectangle in the bounded region that would be parallel to the axis of rotation. So we'll be using this red rectangle here to help set up the integral that will give us the volume of the solid. If we were to rotate this rectangle about the axis of rotation, it would give us one shell or one tube of volume of the solid. And here's a picture of several tubes or several shells that would be used to approximate the actual volume. Our goal is to find the actual volume using this integral here, where we have a vertical axis of rotation. The volume is equal to 2 pi times integral from a to b of p of x times h of x integrated with respect to x, where p of x is the radius function and h of x is the height function. So again, going back to our rectangle, p of x will be the distance from this rectangle to the axis of rotation, this distance here, and h of x would be the height of the rectangle, this distance here. Let's work on determining p of x. This can be a little tricky when the axis of rotation is not the y-axis. Notice how the distance from the y-axis to the axis of rotation, this distance here, is always 4 units, and then the distance from the rectangle back to the y-axis, this distance here, using our rectangle, would always be x units, which means p of x, the distance from the representative rectangle to the axis of rotation, would always be 4 units minus x units, or just 4 minus x. So p of x is equal to 4 minus x, and now let's find h of x. H of x is much more straightforward. Notice how the height of the rectangle is from the x-axis to the corresponding point on y equals x squared, and therefore this vertical length y is equal to x squared. So h of x equals x squared. This is all we need in order to set up the integral to find the volume of the solid using the shell method. The volume v is equal to 2 pi times the integral. Now we're integrating with respect to x. So looking at the bounded region again, notice how we're going to integrate from x equals 0 to x equals 2. So limits of integration are from 0 to 2. The integrand function, again, is p of x times h of x, which would be p of x, or the quantity 4 minus x, times h of x, which is x squared. Let's go ahead and write this as the volume v equals 2 pi times the integral from 0 to 2. Distributing, we'd have 4x squared minus x cubed. Let's go ahead and evaluate this on the next slide. Integrating with respect to x, we have 2 pi times the integral of 4x squared with respect to x would be 4 times x cubed divided by 3, or 4/3 x cubed, minus the integral of x to the third with respect to x would be x to the fourth divided by 4, or 1/4 x to the fourth. Now I need to find big F of b minus big F of a, so we'll have 2 pi times, when x is 2, we have 4/3 times 2 cubed, minus 1/4 times 2 to the fourth, and then when x is 0, notice both terms would be 0. So simplifying, we have 2 pi times, here we have 4/3 times 8, that's 32/3, minus, here we'll have 1/4 times 16, which is just 4. Let's write 4 as 4 over 1. Common denominator is 3. So multiply 4 over 1 by 3 over 3. So we have 2 pi times, here we have 32/3 minus 12/3, which equals 20/3. So the exact volume would be 40 pi thirds cubic units. Of course, we can also get a decimal approximation if we wish. 40 pi divided by 3 is approximately 41.8879 cubic units. Going back to the graph one last time, if we rotate this bounded region about x equals 4, we would get this solid here that has a volume of exactly 40 pi divided by 3 cubic units, which is approximately 41.8879 cubic units. I hope you found this helpful.